Hello viewers, today we will solve this transportation problem that we can see over here. Now if we have a look at this problem, if we add up the demand and supply, the demand is 75 plus 20 plus 50, that is 145, while the supply is only 10 plus 80 plus 15, so it is only 105. So by now we know that if the demand and supply are not matched, we need to put a dummy source or a dummy destination. In this case it would be a dummy source because the supply is falling short. Supply is only 105 while the demand is 145. So we will be putting a dummy source. Now the routine procedure for putting a dummy source is that we insert zeros in that dummy source. For cost values we put zeros. But if we have a look at this question, the question is transportation costs from sources A, B and C to destinations 1, 2 and 3 are given below along with the capacity of their sources and destinations. Since there is not enough supply, some of the demand of destinations may not be satisfied. That is obvious because it is an unbalanced problem. Some demands will remain unsatisfied. The penalty for unsatisfied demand at destinations 1, 2 and 3 is rupees 4, 3 and 2 respectively. So this time what is happening is the question suggests that for the demand going unsatisfied. Now if we remember our routine procedure, the routine procedure is that whenever the demand goes unsatisfied, that is the demand is unbalanced, we put a dummy source, and when we put the dummy source we put zeros. Let us see over here with a very basic question. We have our sources and destinations. Now if we add up the capacity of sources and destinations, we see that it is 50 and 30. So there is a mismatch of 20 units. This mismatch will be worked out through a dummy source or destination. Now at the source we are producing 50, at the destination we are consuming only 30. So there will be a dummy destination. How do we approach for that? These are our sources and destinations. The given costs remain same: 3, 4, 2, 5, 3, 1, 2, 4 and 2. Now the dummy destination that we have added, the convention is that we put a 0 for all these. But in this case, in our question given over here, it says that the penalty for not meeting the demand is 4, 3 and 2. So if some penalty is given, we will not put these zeros, rather we will put those penalties. This is how we approach these kind of questions where we are not just putting a dummy source or a destination, we are also putting up the penalties given in the question. Now let us start with this question and see how we can approach it. Now let us build this table and input the values, then we'll solve it. Now if we count them, we have 95, 40, 145, 90, 105. So we see there is a mismatch of 40. Our sources are falling short by 40. We have a demand of 145 while our sources are producing only 105. So what we'll do is we'll add a dummy source. How do we add that dummy source? This is our dummy source. Now the convention would have been to put a 0 over here, 40, making it 90, 130, 145, then we add 75, 20 and 50, making it 145. Now this is a balanced problem. We have balanced this problem, but the problem is this time we cannot use zeros as the convention suggests. This time we have been said that there are penalties for not meeting the demand. The penalty for not meeting the demand of source 1 is 4, 3 and 2. So we will put a 4, 3 and 2. It will not be 0, rather it will be a 4, 3 and 2. So this is our simple question. Now we can easily solve it. Now the question suggests find the optimal solution. So in order to find the optimal solution, the methods that we know are northwest corner method, LCM and VAM. These are for IBFS. Then for optimization, the method that we generally use is modified distribution. So first we need to find out IBFS using either of these methods, then we'll be finding out the optimization of this problem using modified distribution. Now from all these three methods, VAM is the most efficient one, which generally leads us to the best solution. So we'll be finding out IBFS using VAM, and then we'll make use of modified distribution to check if this is the optimal, whatever solution we have found out. How do we go about VAM? We need to find out penalties. Now the penalties for these rows would be each of the rows 1 and 5. So penalty would be 4. The minimum 2. What is penalty? It is the difference of minimum 2. 1 and 5, 4. Then the minimum are 4 and 6. So the penalty would be 2. Then 3 and 2 are the minimum ones for row C. Penalty is 1. 2 and 3 are the minimum, penalty would be 1 again. For columns it would be 3 and 4 giving me a penalty of 1. 1 and 2 giving me a penalty of 1. Then this time 2 and 5 giving me a penalty of 3. These are our penalties. Penalties. Now, which is the maximum penalty? 4 is the maximum penalty. The rule is that this penalty should not be faced. So, in order to avoid this penalty, we give source A the first chance to make an assignment. When we give the source A the first chance for an assignment, the best cell for A is cost of 5, cost of 1, cost of 7. 1 is the best one. So, it will make assignment in this. 20 and 10. There is a supply of 10, there is a demand of 20. So the deal would be for 10 units. A can supply 10 units, but 2 needs 20 units, destination 2. So they'll make a deal for 10 units. Now as they make this deal, this source is exhausted. It was producing 10, it has supplied 10, leaving me with 10 further. This source is exhausted. Once again, let us find out penalties. Now this source is gone forever. The new penalties would be 4 and 6 giving me a 2, 2 and 3 giving me a 1, 2 and 3 giving me a 1. For destinations 3 and 4, 2 and 3, 2 and 5. Now we see the penalties are 2, 1, 1, 1, 1, 3. The largest penalty being the 3. In this 3, destination 3, we give the first chance that you should fulfill your demands. So destination 3 sees that this is the least cost cell, it will make an assignment in this. Now for dummy there is a supply of 40, there is a demand of 50, they will make a deal of 40 units only. This deal, first thing, dummy source is exhausted. Second thing, out of 50, 40 have been received, so it needs 10 further. Let us find out the penalties once again for rows and columns. Now this is gone forever. We are left with 4 and 6, a penalty of 2, 2 and 3, a penalty of 1, 3 and 6, a penalty of 3, 2 and 4, a penalty of 2, 5 and 6, a penalty of 1. So we see the penalties are 2, 1, 3, 2, 1. 3 is the largest one. Let me go with 3. Who is facing this penalty of 3? Destination 1. So we'll give destination 1 a chance to fulfill its demand. When we give destination 1 a chance, 5 is cut, 4 is cut. The two cells remaining are 6 and 3, of which 3 is the least cost. Now how much can we put in 3? There is a supply of 15, there is a demand of 75. So we will only take 15, will leave 60 due. With these 15, this source is also gone. Now if you have a very close look at this table, we see that source A is exhausted, C is exhausted, term A is exhausted. All three sources are exhausted. Only B is left with a supply of 80. While if we talk of destinations 1, 2 and 3, 1 still needs 60, 2 needs 10 and 3 needs 10. So 60 plus 10 is 70 and 10 is 80. So destinations need 80 units. Source has 80 units. There is only one source. So when there is only one source, it is very simple. You will get 60 from the only source. 60, 10 and finally 10. So all assignments have been made. Let us check it for feasibility. It is a good practice to always check your assignments for feasibility. A demand of 10 fulfilled by 10, 80 coming through 60, 10, 10, 10, 15, 1 short, 40, 1 short. Sources are satisfied. What about destinations? 60 and 10, 75, 10 and 10, 20, 10 and 40, 50. So it is a feasible solution. Now let us quickly check if it is an optimal solution also. What is the total cost? If we were to find out at this point of time, total cost would be 10 into 1 plus 60 into 6 plus 10 into 4 plus 10 into 6 plus 15 into 3 plus 40 into 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All done. Making it a 10, 360, 40, 60, 45 and 80. How much is this? 595. Is it 595? Let us check. 100, 460, 470, 470, 550, 595. This is total cost for our first assignment. Now let us quickly check if this is an optimal solution also. For checking optimality, we'll make use of modified distribution. First let us check, can we at all use modified distribution? The condition is number of assignments should be equal to m plus n minus 1. We have number of assignments 1, 2, 3, 4, 1, 2, 3, 4, 5 and 6. We have 6 assignments. Number of rows 1, 2, 3, 4. Number of columns 1, 2 and 3 minus 1. 6 is equal to 7 minus 1, 6 is equal to. So yes, I can move to testing for optimality. How do we test it for optimality? The matrix was 3 by 4, sorry, I made it for a 4 by 3. Matrix is 3 by 4. We make this matrix, we bring the costs of assigned cells. These are the assigned cells. Let us bring the costs over there. Cost of this cell is 1, 6, 4, 6. Look carefully. Only the costs of assigned cells are being transported. or rather transferred. 1, 2, 3, 4, 5, 6. We had 6 cells, we have transferred these costs. Now we'll quickly check for optimality. You can go through our other videos if you have not seen how to check for optimality. Other videos are explaining it in far more detail. So you can check out those videos. Here we will run through this test. Now these are some U's and these are some V's. Let us have this as 0. If this is 0, the rule is that you can put any of these values as 0. So I have put a 0 over here. Now we need to ensure that U plus V is equal to A. So if this V is coming in, this U is coming in, when we add them U and V, I should get a 6. So what should I put over here? A 6. 6 plus 0 would give me a 6. If these are coming in, 4 plus 0 should give me a 4. 6 plus 0 should give me a 6. So is the condition being fulfilled? 6 plus 0, 4 plus 0, 6 plus 0. What should be the remaining values? If we have a 6 over here, probably minus 3 can do it. 6 minus 3 is a 3. We have a 6 over here, probably minus 4 will help us out. 6 minus 4 is a 2. We have a 4 over here, 4 minus 3 would make it a 1. So these are U and V values. What is the next step? These are the empty cells. We fill in these values using these U and V values, adding them. For example, this 6 and minus 3. If they come in, they meet over here and they are added. So you get a 6 plus minus 3 coming from here, making it 6 minus 3 is equal to. If we take this cell, this 6 climbs here, 3 comes here, you again get a 3. Then this is the empty cell, 4 coming here, minus 3 coming here, 4 plus minus 3, 4 minus 3 is equal to 1. This would again become a 3, this would become a 2 and 0. So first step was make a new matrix, second step was transfer the costs of assigned cells, next step was add these U and V values to get these new values, and last step is subtract these new values, from the original ones. Like I had 5 minus 3 would give me a 2. I had a 7 minus this 3 would give me a 4. 2 minus 1, 5 minus 3, 4 minus 2, and 3 minus 0. Now we can see that this is plus 2, plus 4, plus 1, plus 2, plus 2, plus 3. Now what are these values? These values are the potential savings, the potential improvements that are possible in this cost. This is a potential improvement of plus 2, which means that it will increase the cost by 2. Instead of 595, it will become 597. This 3 tells me it will become 595 plus 3. If there were a minus sign, minus 2 or a minus 4 or a minus 3, it would have meant effectively that the cost will go down. But for now, because everything is plus, we can stop here. We can say that this is the least cost and this is the optimal assignment. This is our final solution. What is our final solution? A2 getting 10, B1 60, B2 10, B3 getting 10, C1 is 15, and finally dummy to 3 is 40. This is our best solution with a best cost of 595. Yes, if this is the first video that you have seen of transportation, you might be a bit confused with this optimization. For optimization, you can check out our other videos in the same playlist which you are watching. There are other videos where we have talked about optimization in detail. You can check out those videos. If there is some confusion how these values came out, you can drop in a comment. We'll try to address them. So this is it for this particular question. Thanks for watching. Bye-bye.
Here are some cards related to the video you just watched. Feel free to browse across them and do leave your comments and suggestions. And of course, don't forget to subscribe if you have not already subscribed. Thanks for watching. Bye bye.